Hello and welcome back to the channel. In this video, we're going to be looking at 8 different Python projects for beginners. I've included timestamps and chapters in the video if you want to jump around. Before we get started, don't forget to like the video and subscribe to the channel to show your support. So we're going to go ahead and create a new folder. So we're going to say open folder. Then here we're going to right click and go to new folder, and we're going to call it Python projects. And we're going to select that folder. And in here, we're going to create a new file. We're going to call it rps.py, which stands for rock, paper, and scissor. So in here, the first thing we need to do is get a plan to what we're going to do. So we're going to be using functions to organize our code, and we're going to be using a new statement that we have not seen before, which is the import statement. So let's start with that. What does the import statement do? The import statement takes code that other people wrote and it puts it inside your code. That means you can use the functions that other people wrote inside your own code. In our rock, paper, scissors project, we're going to be using the random library, which includes a function called randint, which helps us select a random number from a selected range. And we'll see how that is useful in our project. So what is the plan? We're going to have an array that's going to contain the 3 choices that we have, that is rock, paper, and scissor. And we're going to use the randint function to get a random index between 0 and 2, because arrays or lists start indexing at 0, so it's going to be 0, 1, 2 for rock, paper, and scissor, and it's going to be random. That means that is going to be the computer's choice at random. Then we're going to have one function that deals with the logic. That means it's going to compare the computer move and the move we enter, and it's going to spit out a value, or it's going to add to the computer score or the player score depending on what move we make. Then we're going to have another function that's going to calculate the final score. That means it's going to compare the player score and the computer score, and it's going to print out who won. And finally, we're going to have a play function, which is going to consist of a loop that's going to run a certain amount of times. That means it might run 5 times if we want 5 rounds. That is going to be decided when we run or when we write the code. So let's get started. So as I said, we're going to use the import keyword to import a library called random, where we're going to be using a function from this library, and I'm going to be showing you the syntax when we get there. So we're going to have a list of choices, as we said. These are the list where the computer is going to take its choice from. So it's going to have rock, it's going to have paper, and it's going to have scissor. And we're going to initialize the player score and the computer's score, which is going to both be 0 at the start of the round. So we're going to have 0 for the player score, and we're going to have 0 for the computer score as well. Now we can start writing our function. So we're going to start with the logic function. That means it's going to compare the player move with the computer move. So we're going to use the def keyword, and we're going to call it rps logic, and it's going to take 2 parameters or 2 inputs. That's going to be the player's move and the computer's move. So we're just going to call it p move for player move and c move for computer move. So what are we going to do here? We're just going to be comparing these moves. So let's start with if the computer move is equals to rock. So in this case, there's going to be 3 possibilities. We could also play rock and it's going to be a tie. We can play scissors and the computer is going to win that round. And we can play paper, we would win that round. So let's start with when we both say rock. So for clarity purposes, we're just going to print out what each move is, what that means what our move and what the computer's move is, we're going to be using what is called a formatted string. What is a formatted string and what makes it different from a normal string? What makes it different is that we can substitute variables directly into the string. What does that mean? So the syntax is simply f followed by double quotes. So in here we're going to say computer, actually we are going to say player first, player, and here we are going to substitute the move that the player made, which is going to be p move, and we'll also print out the computer's move. So we're going to put a little bit of space and we're going to say computer, and we're going to substitute in c move, which is going to be the computer's move. And we're going to have multiple of these, so to save time we're going to use copy and pasting. So we're going to copy this, and here we're going to first deal with the 3 moves where the computer says rock and we say something else. So we're going to have one and we're going to have another one. In all these cases the computer is going to have rock. So in the second case we're going to change our move and we're going to make it paper, and in the final one we're going to make it scissor. So that means we've dealt with all the replies we could have when the computer plays rock. So what we need to change here is we need to change the remaining if statements. Here we're also going to be introduced to a new syntax called else if. What does that do? So we have an if, we've seen an else. So what does an else if do? So it's going to do the if statement, it's going to compare whatever condition we've put in the if statement. Then it's also going to check the else if statement. So that means it's just like else, but when we have another condition to check. So when we have multiple conditions to check in one block, we use a series of else if statements. So here we're going to have an else if. The syntax is ELIF, which is abbreviated to ELIF, which stands for else if. So we're going to have more else if statements. So what are we going to do? So when the computer move is rock and our move is rock, that means there is nothing that updates in the player score or in the computer score because it's a tie. But we're just going to print out each player score in each round so it's more clear. So here we're going to print out, let's just print an empty line. And between those empty lines, we're going to have the player score and the computer score. So we're going to print out computer followed by computer score, and we'll also have player followed by the player's score. So that is going to print the player score and the computer score in each round. And when the computer's move is rock and our move is paper, that means paper beats rock, so the player is going to get an additional score. So here we're going to add 1 to player's score. So we're going to use the syntax we've seen before, which is plus equals 1. This is going to add 1 to the player score. Then again, we want to print out the current score, so we're going to copy this and paste it here. And in the third elif statement, the computer is rock and we are scissor. That means the computer beats us, so we're going to increase the computer's score by 1. And again, we're going to print out the computer and player score. Now we've dealt with all the possibilities when the computer move is rock. So we're going to go to the next move, which is going to be, let's say it's going to be scissors. So we're going to again paste. Actually, we need to copy again. So we are going to just copy this else if statement. And we're going to paste it. And here we're going to make the computer's move scissors. So it's going to be scissor. And let's just start with the player move also being scissor. So in this case, the computer score won't be updated, so it's going to be a tie. And here we're going to copy this and paste it 2 more times to cover all the possibilities when the computer move is scissor. So 1, then 2. So here on the second one, we're going to make our players move. Let's make it paper, which means the computer move beats us, so we're going to increase the computer score by 1. And in the final one, we're going to make this rock, which means we beat the computer, so we're going to increase our score by 1. And finally, we're going to deal with the conditions when the computer move is what is left, that is when the computer move is paper. So let's just copy one of these, then we'll paste them here, and we're going to make the computer move paper. So when the computer move is paper and our move is paper, it's a tie, so no one's score is going to be increased. And we're just going to copy this and paste it 2 more times, cover all the possibilities. So the second one, we're going to make our move, let's say scissor. So that means we beat the computer, so we're going to add our score. So we're going to increase player score by 1. And in the final one, we're going to make our move rock. That means the computer beats us, so we're going to increase the computer's score by 1. So you can pause the video and look at this logic. It's actually quite simple, but it's a bit too much to type. So this is all we need for the RPS logic function. That means this is going to check our logic. The next function we're going to have is the function that's going to print out the final result. That means which side won. That means did the player win or did the computer win. So here we're going to define another function. We're going to call it final score. It's going to take no input. It's only going to display the winner. So what it's going to do is it's going to compare player score and computer score. So if the player score is greater than the computer's score, it's going to print out player 1, and we're going to use the else if statement. So it's going to check if the player score is less than computer score, then it's going to print computer 1. And finally, we're going to have an else statement. That means if neither of these are true, that means player score is equal to computer score, and in that case it's going to print it's a tie. So this is just the final score function, which is just going to print out the final score. Now we have one function remaining, which is the play function, which is going to contain the loop that runs as long as the game runs. So we're just going to call it play. Again, it takes no input. And here we're going to enter the number of rounds, which in our case, let's just make it 5. And we're going to do the current round, which means at the start, it's going to be 1. So our loop is going to run as long as current is less than or equal to round. And in each round, we're going to increase current. So what are we going to do? We're going to have a while loop with the condition while current is less than or equal to rounds. We're going to do the following. So what are we going to do here? We're going to take the player's input. First, we're going to say, we're just going to call a player, and we're going to take an input from the player. We're going to say rock, paper, or scissor. And we're going to take the player's input. Next, we're going to have the computer's input. As we said before, we're going to be using the random library, and we're going to get a random integer from 0 to 2. Why from 0 to 2? Because our list contains 3 elements. So the first element has index 0, second has 1, and the third has 2. So we're going to get a random number from 0 to 2 each round. That means the computer's choice is always going to be random. So to do that, we're going to go down and say computer is equals to choices, and we're going to access one of the elements from the list using square brackets. And in here, we're going to use the random library, and we're going to do that by putting in the library's name followed by a dot. So here we see all the functions in the random library. As we said, we're just going to be looking at one, which is the rand_int function. It's going to take two numbers, the start and the end of the random integer we want. So we want it from 0 to 2. So this is going to get us our computer's choice. And once we have our computer's choice, what do we want to do? We want to call one of our functions. Which function are we going to call? The logic function, which is RPS logic, and we're going to give it two moves, as we said. Here we call them pmove and cmove, and in those places we're going to have player, which is going to be the player's move, and we're going to have computer, which is going to be the computer's move. And once we get that logic, that's going to work out the scores. Then we're going to have current plus equals 1. So we need to increase current each time, so our game just runs for 5 rounds. And finally, after we've gone through the loop and the game is over, we want to display our final score. So what are we going to do? We're going to call our final score function. So that is it. That is all we need to do. And finally, we're just going to call our function. We know how to call a function. We use its name. So we're going to call the play function because we want to play the game. So this is all the code. If you want to pause and see. And now we are going to save our file and see if we get errors so we can fix them. So we're going to press play. It asks us for rock, paper, scissors. Let's just put in paper. We get an error. So let's see what this error says. It says cannot access local variable player underscore where it is not associated with a value. So when did we use this? So it's getting an error when we're increasing player score by 1. So that is in the logic function. So what is the problem here? When we increase player score by 1, we're supposed to be increasing the global or the variable outside of the functions. We're going to increase them by 1. So we're getting an error because inside the function we do not have a variable called player underscore score. So if we want to use the global one, or the one that works for all functions, the one that's outside all functions, we need a special statement, which I'm going to write right now. We need the global statement. So we're going to say global player underscore score, and we'll also have that for the computer score. So this means in this function, use the global or the ones that are outside the function, use those variables for player underscore score and computer underscore score. So that is what these two lines do. So now we're going to save our file again and we're going to run it. We're going to run it from the terminal this time. We're going to say Python 3 followed by the name of our file. Okay, it asks us for rock, paper, or scissors. Let's put in paper. Okay, we played paper, the computer played rock, that means we beat it. So we got an additional point. Let's just play rock. Again, we played rock and the computer played scissors, so we beat it again. Let's play rock again. Oh, this time the computer played paper, so it beat us, so the computer score is updated. Let's play scissors. Let's play scissors. It's a tie, that means we both played scissors, so the score is the same. And we're at how many rounds did we play? This is 1, 2, 3, 4. So this is the final round. So if the computer beats us this round, that means it's a tie. If we beat them, then we win. So let's put in rock. Unfortunately, the computer played paper and it became a tie, so it prints out it's a tie. So you can edit this code and you can increase the number of rounds if you want. All you have to do is go to the play function and increase this round variable. You can play around with the code. So this is the project on a simple text-based rock, paper, scissors game. So in order to implement this weather application in Python, we're going to be looking at one new concept, which is an API. What is an API? An API is a method in which two different softwares communicate with each other. So if we want our Python software to communicate with other softwares, for example, on the web, we would be using an API. And in order to get information from that API, we need to request it. That means we need to get the information. And in order to get the information, we're going to use a Python library using the import statement that we've seen before. So we're going to be importing a library called requests. So the request library has a function called get, which is going to help us get different information from APIs. So let's just get into the code and we'll explain each line as we go through it. So the first thing you have to do is go to your terminal and you need to install the requests library since it's not default to your Python installation. So you're going to go to your terminal. If you're on Windows, you're going to type in pip install followed by requests, and if you're on Mac, you're going to type in pip3 install requests and press enter, and it will download the request library for you. I already have it downloaded, so it won't be downloading on mine. After you've done that, you can clear your terminal, and now we're going to get started with the code. So let's just call it weather.py. Here we're going to import what we just downloaded. So we're going to import requests. So what is our plan here? So in order to build our weather application, we need to get the weather from somewhere. So we're going to be getting it from an API, a weather API to be specific, which we'll be looking at where to get it. And our program is going to ask the user to input a city, and using that city as an input, it's going to display the temperature, and it's also going to display the weather in that given city. So let's just get started with what we know. So we know how to take user input. So we're going to put in, let's just call it user input, and we're going to set it equal to input, and we're going to prompt the user to enter a city. So this will get us the user's input. The next thing we need to do is we need to request that information, so the weather information. And to do that, we're going to be using a free API. So to get that API, we're going to open our browser and we're going to type in open weather API. Then we're going to click on the first link, which is weather API. We're going to click on it. Then it's going to take us to this page. So you're going to sign up. I already have an account, so I'm going to sign in. All you need to sign up is an email and a password. So it's very simple. You just sign up. Once you've signed in, you'll be greeted by this page. Here, all you need to do is go to the tab that says API keys. You're going to press on it, and it's going to show you a key, your key. That is the one that starts with F on my screen. It could be different on your screen. It's going to be different on your screen. So whatever's under the key column, you're going to copy this, and you're going to go back to your code, and you're going to create a variable called API key, and you're going to set it equal to a string, and inside that string you're going to paste in the code you just copied. So this is our key that's going to let us access the information we want from the Open Weather API. So once you've done this, you can close out of your browser because that's the only thing we need. Next, we're going to type in a variable. We're going to create a variable called weather data, and we're going to be setting it equal to the get function that we were talking about, which is requests.get. And in here, I'm going to paste a link, which will be in the description as well. And after I paste it, I'm going to explain what each part of the link means. So I'm going to go ahead and paste it. So here is the link. So the link is a formatted string. In this formatted string, what matters is what we have after the weather word. So here we have Q equals. Here we're going to put in the city name. So in our case, we are taking that from the user. So here we're going to input the city's name, and the next parameter is units. So what you have here is the units. So you can either have it metric if you want your temperature in degrees Celsius, but if you want it in degree Fahrenheit, you'd have to change this to empirical. So that is for the units. Next, we have our APP ID, which is going to be our API's key that we copied from the website. So that is going to be inserted here. And once we have this link, all we have to do is look at what data we get. And this data is going to be an object. So in order to view it in our code, we have to convert it to something called a JSON. A JSON file is very similar to a data structure that we have seen before, which is a dictionary. So it's basically a dictionary. So let's just convert it and print it out to see what it looks like. So we're going to print weather data.json. That's how you convert it to JSON. So we're going to save our file and we're going to run it. It says enter city. I'm just going to enter Addis Ababa. Here you see the JSON representation of our data. It's using curly braces, that's why I said it looks like a dictionary. Again, it has key value pairs. So this chord is a key, then it has a value. Again, this weather is a key and it has a value. So basically it's the same as a dictionary. So in our program, what we want to display is the temperature and the actual weather. So in order to get that, the weather is going to be right here, which is rain. So in order to access that, we need to first access weather, and inside weather, we need to access the first element of the array, which is going to be this object here, this dictionary here. Then in that dictionary, we can get the main key, and using the main key, we can get the weather. So that's the first thing we want. The other thing that our program is going to be displaying next to the weather is going to be the temperature. And in order to access the temperature, we would have to go into main, then into temp, then we would get the temperature in degrees Celsius. So now let's just access all the elements that we want. So we're going to create a variable called weather, and we're going to set it equal to weather data.json. And in here, as we said, to access the weather, first we're going to go into weather, to the weather key. Then it's going to be an array, and we want the first element of the array, so we're going to have 0 because arrays are indexed from 0. Then inside the array, we want to access the key main, so we're going to use another square brackets and access main. So this is going to give us the weather. The other thing we want is the temperature, so we're going to create a variable called temp. We're going to set it equal to weather data.json. Then again, we said we wanted to first access main, so we're going to access main, and inside main we wanted to access the temp key, so we're going to have temp. So this is going to give us the weather and the temperature of the given city. Next, we're going to display it in a good format, so we're going to use a print statement, a formatted string. First, we're going to print out the city, which is going to be the user input. And on a new line, using the new line character, we're going to print weather, followed by the weather variable we just got. And again, on a new line, we're going to have temperature, followed by the temperature variable we just got, which is going to be temp. So this is going to print out the weather and the temperature. So we're going to save our file, and we're going to run it from the terminal this time using Python 3, followed by weather.py. It asks us to enter a city. We're going to put in Addis Ababa. As you can see, it gives us the weather, which is rain, and it gives us the temperature, which is 16.49 degrees Celsius. So we can add a C here for clarity purposes. Another thing we need to do is error handle. We need to error handle because we're requesting something from another website or another link. So that link might not work. So in order to check that, we need an if statement. So if the weather data request works correctly, it's going to return a status code of 200. So we need to check if that status code is equal to 200. So we're going to have an if statement that's just going to check if weather data dot status code is equals to 200. So if it's equal to 200, we want to do everything that we said here. So we're going to indent it using the tab, and we're going to have an else statement. So if the status code is not 200, then we want to print out that we have faced an error. So we're going to say an error has occurred. So now we can save our file and see if it still works. So we're going to run Python 3 weather app again. So it asks us to enter a city. This time let's just enter London. As you can see, it prints out the weather and the temperature in London, which is cloud, and the temperature is 17.28 degrees Celsius. So this is it for a simple weather application in Python. So we're going to create a new file. We're going to call it currency.py, and from the previous project we've looked at requests or the requests library, so we're going to be using that library in this application as well. For those of you who haven't seen that video, to install the requests library, you have to go to your terminal and type in pip3 install followed by requests. This is for Mac users, and for Windows users you type in pip install followed by requests. And once the install completes, you might need to restart your editor, but after that it should work. So we're going to start by importing requests. So what is our plan here? We need to take 3 inputs from the user. That is going to be the source currency or the currency they're converting from, and we need to take in the destination currency or the currency they want to convert to, and finally we're going to take in an amount. So those are the 3 inputs we need from the user. So these are basic, so let's first write those out. So the first thing we're going to take is the source currency. So we're going to call it from currency, and we're going to set it equal to input, and we're going to ask the user to enter the source currency. Here we need to remember an important fact that we looked at in the Learn Python playlist. So in the from currency and the to currency, it doesn't matter, but when we come to the amount, there is something that we need to do to the input. To give you a hint, it has something to do with casting. So we'll get to it when we get there. So the next input we want to take from the user is going to be the to currency, or to what currency they want to convert to. So this is going to also be an input, and we're going to prompt the user to enter the destination currency. And finally, we need to take the amount of money that they want to convert from the user. So we're going to say amount equals to input, and we're going to prompt the user to enter the amount. So as I said before, we need to do something here. That is because the input function by default returns a string. So we need to convert it to the proper data type, which is going to be float in this case. We won't make it an integer because the amount could be a decimal number. So we're going to cast it to float, And if you remember how to do that, we type in float, and in parentheses, we're going to have our input statement. And the last thing we need to add before we get to the request is that in our API, the from currency and the to currency, so when it's like USD, AUD, they're usually going to all be in capital letters because they're just 3-letter words. So to make our input appropriate, we can convert the input directly to uppercase using the .upper function. So by adding the .upper function to our input, it's going to automatically convert whatever the user puts in to uppercase letters. So we're going to .upper both of our currency variables, and now we're ready to request for the data that we want. So this is going to be a little different from the previous request that we used for the weather application, because this API does not require any API key, which kind of makes it more simple. So here we're going to create a variable called currency data, and we're going to set it equal to requests.get, and in here, as usual, we're going to have a link which I will be putting in the description below, so you can copy and paste it. Here I'm going to copy and paste it as well. So here what we need to focus on is the variables that we are inputting. So for the amount, we are going to set it to the amount that the user inputs, and for the from, we're going to set it to the variable from currency. And finally, in the to spot, we're going to put in the to currency we also took from the user. So this is the request to get the currency data. So after this, as we did before, we're going to print out the JSON form to see what we have to do in order to access the values that we want. So we're going to print out currency data.json. So we're going to run our file. It asks us to enter our source currency. Let's just put in USD for United States dollar, and our destination currency to AUD for Australian dollar. And we're going to enter an amount, let's just say 100. And as you can see, as the previous project, we get a dictionary that contains all the values that we want. Here, the value that we wanted to access is the one found here, the 151.75. So in order to access that, we need to access the key, which is going to be rates. Then inside rates, we're going to access the input from the user, which is going to be the to currency. So let's write that out and see how it looks. So we're going to remove the print statement because we do not need it anymore. So we're going to create a new variable for the converted amount. Let's just call it converted. And we're going to set it equal to currency data.json. And in this JSON, as we said, the first step is to get into the rates. So we're going to access rates, and inside rates, we're going to access whatever to currency is. So whatever the destination currency is. So we're going to substitute here to currency. So that is going to give us the number that we want. So once we have that, we can print it in an acceptable format. So we're going to have a formatted string. So we're going to say amount, which is going to be the initial amount the user has, followed by the from currency, or the currency that the user wants to convert from, followed by, we're going to say is equivalent to, then we're going to have the converted amount, followed by the to currency. So that is all for the print statement, and let's save our file. We're going to run it again. We can run it from the console this time using Python 3, followed by currency.py. That asks us for the source currency. We're going to put in USD. our destination currency, we're going to put AUD, and our amount, let's just put in 800. As you can see, it prints out 800 United States dollar is equivalent to 1,214 Australian dollars. So it works correctly. There is one last step that we did in the Weathers app that we have to do here again because we are requesting for data. That means we need to check if the request was successful. And in order to do that, we need an if statement that's going to check the status code. So we're going to have if currency data.status code is equals to 200. That means it has succeeded. So if it's equal to 200, we want to do the following. So we're going to tab them in, and we're going to have an else statement. That means it was not successful. So here we're going to print out an error occurred. So finally, let's check if it works. We're going to run it again. Our source currency, this time let's put it as euros, and our destination as USD, and we can put in an amount 350. As you can see, it prints out 350 euros is equivalent to 384 US dollars. So our currency converter works perfectly. So this is a simple currency converter in Python. We're going to have a simpler project as compared to the previous weather application and the currency converter. That is because we won't be using the requests library. We're going to be building a simple body mass index calculator, a BMI calculator, that's going to calculate our BMI, and it's going to tell us whether we're underweight, overweight, or normal weight. So let's just get started. We're going to create a new file. We're going to call it bmi.py, and in this file we need to get our plan ready. So what information do we need from the user? So for information's sake, we are going to take the user's name. We're also going to take their height. We're going to take their weight. So the height and the weight are going to directly be used to calculate their BMI. And again, for information's sake, we're going to also take in their age. So this is just a series of input statements. So let's get started. So let's start with the name. So the name is going to be an input, and we're going to prompt them to enter your name. The next information we need is their age, which is also going to be an input, and we're going to ask them to enter your age. Here again, we need to do a little bit of a modification to the input. That is because age is a number, so we need to cast it to a number since the default return type for an input is a string. So we need to cast it to an integer because age is an integer number. So we need to cast it to an int. So that is going to deal with our age. The next input we're going to take is going to be their weight. So we're going to input, we're going to ask them to enter your weight. So in our case, we want the weight to be in kilograms, so we're just going to put kg. And finally, we want their height. So we're going to have a height variable. We're going to set it to input. So we're going to prompt them to enter their height, which we'll be accepting in meters. And finally, we need to convert the types of weight and height. So our weight is going to be a floating number because it's going to also have decimals. So we're going to cast it to float. Again, our height is also going to be a float because it's going to contain decimal numbers. So we're going to also cast it to float. And now we have all the information that we need from the user. So now we can go ahead and start calculating their BMI. So we're going to create a variable called BMI, and we're going to set it equal to the formula of BMI, which is weight divided by height square. So what we need to do is we're going to input weight from the user and we're going to divide it by height square. So this is, I think, the first time we're seeing it on the channel. So to square a variable or to square a number, we're going to use double asterisk. So it's going to be 2 asterisks and 2. This means get the height and square it. We put in the brackets so the precedence won't be messed up. So first we're going to have the weight and we're going to divide it to the height square. So this is going to give us the BMI of the user. And once we have this value, we're going to tell the user if they're underweight, normal weight, or overweight. So we're going to use a series of if statements. So the first if statement is going to check if our BMI is less than or equals to 18.5. So it's going to be if BMI is less than or equals to 18.5, in which case we're going to print out the text, you are underweight. And we've seen this syntax before, which is an else if statement. That means it's an else, but it has its own condition. So the syntax is elif followed by the condition. In this case, it's going to be when the BMI is between 18.5 and 25. So we're going to say it's going to be greater than or equals to 18.5, and it's going to be less than 25. So it's in between those two values, in which case we're going to print you are normal weight. And we're going to have another else if statement, which is going to be concerned with the values between 25 and 30. So we're going to have 25 less than or equals to BMI less than 30. In this case, we're going to print out you are overweight. And finally, we have one last category, which is going to be greater than 30. So we can just use an else statement because that's the only possibility left. So we're going to use an else statement and we're going to print out you are obese. So these are the if statements that are going to calculate what you are based on your BMI. So we can save our file and we're going to run it using the Python 3 command, followed by the name of our file, which is bmi.py. It asks us for our name. I'm going to put in Avel Gedio. Age, I'm going to put in 19. Weight, I'm going to put in 70. Height, I'm going to put in, it says in meters, so I'm going to put in 1.71. And it prints you are normal weight. But in our case, we want to show them their BMI. So before we say you are normal weight, we're going to print out the BMI. So we're going to go back to our code, and underneath our BMI formula, we're going to print a formatted string that says your BMI is followed by whatever we got in the BMI variable. So we're going to run our program again, put in our name, our age, our weight, and finally our height. And it prints out your BMI is 23.938. As you can see, this is very long. So we want to round down our BMI to just 2 decimal places. So here we're going to go to our BMI. Then we're going to use a function, a built-in function in Python, which is called round, which takes in 2 numbers. The first is going to be the variable that we want to round, and the second is going to be to how many decimal places that we want to round. In our case, we want it to be rounded to 2 decimal places, so we're going to put in 2, and we're going to close our bracket, and we're going to save our file again, and we're going to run it for the final time, I hope. So we're going to run it again, put in our name, we're going to put in our age, then our weight, then our height, As you can see, it prints out your BMI is 23.94, so it's been rounded, and it also prints out what you are based on your BMI. So this is a very simple project that calculates the BMI of a user. So we're going to be coding a project that's going to take in a text file and it's going to return the word count. So we've seen this in Microsoft Word, Google Docs. At the bottom corner, they usually display the word count. So we're going to be taking in a text file and we're going to be returning the word count. So in order to understand this video better, it is recommended that you watch the file handling video, which deals with the open function, the read function, all the functions we'll be seeing in this video. So you can refer to that video if you don't understand anything. So we can get started. So let's create a new file. We're going to call it word count.py. So the first thing we need to do is set out a plan. So what do we need to do? From the user, we need to take one input. So that input is going to be the name of the file. So after we take in the name of the file, we're going to open it using the open function, the built-in open function. We're going to be opening it in read mode because all we want to do is read out the contents. So once we've opened it in read mode, so we're going to be storing all the contents of the file in a variable, and we're going to be using a new function that we haven't seen before, which is the split function. What the split function does is it takes in a large string or a short string. It just takes in a string, and based on the delimiter that you provide it, or if it's empty, the delimiter by default is going to be the space character. So it's going to create a list of items and it's going to separate your string by the spaces and it's going to create a list. So I'm going to show you what that looks like when we write the code. And finally, after we've got that list, we're going to be using the built-in len function, which is going to give us the size of our list. And that size is going to be equal to the word count of the file provided. So that is our plan. So we're going to get into the code now. So the first thing we need is the file name. So we're going to take that from the user. So we're going to create a variable called file name and we're going to set it equal to input. And we're going to prompt the user to enter the file name. And once we have the file name, we're going to be using the open keyword or the open function. So inside the open function, it takes in two parameters. One is the name of the file and the other is the mode we want to open the file by. So the name of the file in our case is going to be file name, which we took from the user. And the mode we're going to be opening it is going to be in read mode. So we're going to have R. And once we open our file, we're going to put it in a variable called file and we're going to set it equal to open. And now once we've opened our file, we can access different functions like read, which we'll be accessing in this video. So what does read do? It's going to give us all the contents of the provided file. So we're going to have contents, which is going to be the variable name, and we're going to store inside it file.read. So in order to see this in action, we're going to create a text file in our directory. We're going to call it hello.txt, and we're going to open that file and we're going to type in hello, my name is Abel and welcome to my YouTube channel. And we're going to save this and we're going to go back to our word count file, and to see what the contents are, we're just going to print it out using the print function. We're going to print contents. We're going to save our file and we're going to run it using the terminal. Our file name is word count.py. It asks us to enter the file name, which is hello.txt. as you can see, it prints out all the contents of the hello.txt file. So it's working properly. And once we have this, we need to use the split function. So first let me write it out, then I'll explain how the split function works. So let's just create a variable called words, and we're going to set it equal to contents dot split, which is going to create a list. So let's just print it out to see what happens. Let's print out words. We're going to save the file and we're going to run it. It asks us to enter the file name. We're going to put in hello.txt. As you can see, it's created a list of each and every word in our file. That is because the delimiter in here is empty. That means it's going to be space by default. So it's going to be each word of our file is going to be stored in a list. So that is how the split function works. So once we have that list, that means our word count is going to be equal to the number of elements in our list, and we're going to be using the len function to find the length of our list. So in order to use the len function, we just write len, and in parentheses we're going to put in the list that we want to know the length of. So in this case it's going to be words. So once we have the length of our list, we're going to store it in a variable called numWords. So this numWords is basically the word count of our file. So once we have that, we're going to have a print statement, which is going to print a formatted string that says the file followed by file name contains, and we're going to sub in numWords contains these amount of words. So if we wanted to put the file name in quotations so it is different from the remaining of the text, we can put double quotes around our file name. But as you can see, that brings a problem because double quotes are used for strings, are used to define strings. So in order to use normal double quotes, we need to escape them. That means we need to use the escape character. As we've seen before, when we typed in a new line, the escape character is a backslash. So before our double quotes, we're going to put in a backslash, and we're also going to put in a backslash for our first double quote. And that means now these double quotes act as normal double quotes and they do not act as strings. So once we do that, we can save our file and we can go to the terminal and run it. Our file name is wordcount.py. It asks us to enter the file name, which is going to be hello.txt. So it prints out the file hello.txt contains 11 words. So finally, let's just check if that is correct. So we're going to go back to our hello.txt file and we're going to count the number of words. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So our program works correctly. So this is a simple implementation of a word count project in Python. So what is a palindrome? A palindrome is a word that is spelled the same when you read it from the front and when you read it from the back. For example, Bob is a palindrome because B-O-B. Let's just create a new file to see everything. So we're going to call it palindrome.py. So as I said, for example, if we had Bob, so if you looked at Bob from left to right, it's Bob. And if you also looked at Bob from right to left, it is also Bob. So these type of words are called palindromes. So in this project, we're going to be creating a program that's going to check if a word is a palindrome or if it's not. So we're going to start by creating our plan. So what are the things that we need? First, we need to take an input from the user. So it's going to be the word that we're going to be checking. And once we have our word, we're going to create two variables or three variables. The first variable is going to be a number and it's going to be 0. So it's going to start, it's going to point to the first character of our string. We're also going to have a second variable, a second number that's going to point to the end of our list. And finally, we're going to have a third variable, which is going to be a boolean, either true or false. So it's going to be a variable called isPalindrome. So it's either going to be true or false. And using the two numbers that point to different parts of the string, we're going to have a while loop that's going to check if both values of the word that we are given is the same. So it might not make sense now, but when we write the code, it's going to make much more sense. So let's get started. The first thing we need to do is take user input. So we're going to call it word. So we're going to create a variable called word, and we're going to take input from the user. We're going to ask them to enter a word. We want the word to be a string, so there is no casting required here. So once we have our word variable, as I said, we're going to have two pointers, one at the beginning of the word and one at the end. So let's just call it I. So I is going to be 0. As we said with lists, as indexing starts with 0, the same is true for strings. So for a string, let's say for the string Abel, A is at position 0, B is at position 1, E is at position 2, L is at position 3. So it's the same as lists. So I equals 0 is going to point at the beginning of the word, and J is going to point at the end. So how do we find the end of the word? We're going to use the len function that we used in our previous project. So we're going to say len of word, but len of word won't give us the correct value. Why is this? This is due to the indexing starting from 0. So again, let's look at a word example. So let's say we have the word example. Here, if we called len of word, we would get 1, 2, 3, 4, 5, 6, 7. We would get 7. But the problem is we want J to point to the last character of our word. But the last character of our word is not at index 7, but at index 6. That is because when we count, we start counting from 1, but indexing starts from 0. We need to subtract 1 from the length of the word in order to get the correct index. So now we have two variables that point to the start and to the end of the word. And finally, we're going to have a variable called isPalindrome, which is either going to be true or false. So initially, we're just going to put it to true. So these are the three variables that we're going to need. And finally, we're going to look at the while loop. The while loop is probably the most complex part of this project, so listen closely. So we're going to have while, and the condition is going to be I less than j. So this might not make sense now, but we're going to look at it through an example. So we're going to have I less than j. Then if the word at index I, that means it's going to be one character. If that is not equal to the word at index j, then that means the word is not a palindrome. So we're going to set is_palindrome to false. And once we set it to false, we're going to be using a break statement. What does a break statement do? As soon as our code reaches a break statement, that means it's going to exit whatever loop it's in. So if we have break here, that means when a character is found to be different, it's going to set isPalindrome to false, and it's going to break our loop. So it's going to get out of our loop. So that is what we want to do. And the final step in our loop is going to be incrementing and decrementing two variables. So first we need to increment I by 1. Since it's starting from 0, it's going to go through the word. And we're going to decrement j by 1. So we're going to use j minus equals 1. So let's see how this code would work. So again, let's go back to the example word. So here, what's going to happen, I is going to be 0 and j is going to be the length of the word -1. So j is going to be at e and I is also going to be at e. Since they are the same, the loop would continue. And in the next iteration, I would be at x and j would be at l, which means they are different. That means the word is not a palindrome. So when these two characters are not equal, is palindrome is going to be set to false and we're going to break out of the loop. So that is what happens when the word is not a palindrome. So let's see another word that actually is a palindrome. So let's see Ababa. So this is a palindrome. So let's see how the loop deals with it. At first, I is going to be a and j is going to be a. So they're equal. So it goes to the next iteration. Then I would be at b and j would also be at b. So that is correct. So it's going to continue the loop. And in the next iteration, both I and j are going to be at e. But what does this mean? That means I is going to be equal to j. And that is going to violate our while condition. So our while condition is I is less than j. So when I and j are equal, that means our while condition is going to stop. And it stopped without getting into this if statement. That means it stopped without setting is palindrome to false. That means is palindrome is still true. That means the word given is going to be a palindrome. So now we can get rid of this example and we can actually see the code in action. But first we're going to print out different statements based on the value of is palindrome. So we're going to have an if statement followed by is palindrome. That means if is palindrome is true, we're going to run this statement. We're going to print the word followed by the actual word, which is in the variable word is a palindrome. And we're going to have an else statement. That means if is palindrome is false, we're going to print the word and we're going to substitute in word is not a palindrome. Again, we forgot f here. That means we need to convert the string to a formatted string. So now we can save our file and see if it works properly. So we're going to run our file using Python 3, followed by the name of our file, which is palindrome.py. So it asks us to enter a word. First, let's try a word that is not a palindrome. Let's put in our previous example word, which was example. As you can see, it prints out the word example is not a palindrome. Let's run our program again. And this time, let's put in an actual palindrome. Let's say Bob. As you can see, it prints the word Bob is a palindrome. And one last time, let's check if it works for Ababa. It prints out the word Ababa is a palindrome. So this is a simple implementation of a palindrome checker. For those of you that are interested, there is one way to reduce this code all the way up to one single line. So if you find that line, put it in the comments below and let me know. So this is all about the palindrome project. Our project is going to take in normal English sentences and it's going to convert them into Morse code. This is a very interesting project, so let's get started by creating a new file. We're going to call it morse.py. So now we're going to talk about our plan. So what is our plan here? So here we're going to be using a data structure that has been in many of our projects here. We've seen it many times, which is a dictionary. So in our previous projects, we've seen them in the JSON file format, which is those files that we got from the internet from different links. But in this project, we're going to be creating our own dictionary. Then once we have our dictionary, we're going to have key value pairs. So what are these keys and what are these values? So in our project, the keys are going to be the 26 letters and it's going to be from 0 till 9. So those are going to be the keys. And the values is going to be the corresponding Morse code. So we're going to be using this dictionary. And once we've created our dictionary, we're going to take a message from the user. So that message is going to be what is translated into Morse code. And once we have the message from the user, we're going to have a for loop that's going to go through the message, and it's going to replace each character with its Morse code equivalent. So at the end, we will have a fully translated Morse code. So let's get started. So as I said, first we're going to have our Morse code dictionary. So I'm going to just type in the first few elements and I'm going to copy and paste the rest. So in order to save time, I'm also going to leave the whole dictionary in the description so you can also copy and paste it. So we're going to have a dictionary called Morse code. And for example, the first element is going to be, the key is going to be A, and the value for A is going to be dot slash. So this is the first element. We could have also B is going to be the key, and its corresponding Morse code is going to be the value, which is slash followed by 3 dots. As you can see, we can do the rest. So in order to save time, I'm just going to copy and paste the rest. So I've copied and pasted the rest of our dictionary. So our dictionary contains keys from A to Z, as you can see, all the way to Z. Then once it finishes from A to Z, it continues with 0 all the way till 9. So that is going to be our dictionary, which is going to be our key that we are going to be using to convert the user's message into Morse code. So as we said, our next step is going to be taking input from the user. We've seen this hundreds of times, so we're just going to create a variable. Let's just call it message, and we're going to set it equal to input, and we're going to prompt the user to enter their message. There's one little modification we need to do. So once they enter their message, we need to convert it into uppercase. So why is this? Since we'll be using the dictionary above, and the dictionary above uses all capital letters, we need the message to correspond to that. So as soon as the user inputs a message, we're going to convert it into uppercase using the dot upper function. So now we have the user's input and we've converted it into uppercase. Then we're going to have an empty string. So this empty string is going to store our translated message in the end. So we're going to call it translated message. And for now, it's going to be an empty string, but we're going to be adding the Morse code into it using the concatenation operator. Now we can start writing our for loop. So we're going to say for, then followed by our temporary variable char, which is going to store each character in our message. So we're going to say for char in message, we want to do the following. So we're going to say if char, or if each character is in message, I mean if it's in Morse code, that means if the character is from A to Z, and if it's from 0 to 9, we want to do the following. So we're going to say translated message, which is our empty string. So we want to add the following into it. We're going to add Morse code, and we're going to access each character's Morse code representation using the square brackets as we've seen before. And here we're going to put in char. So for example, if our message was Abel, so for the first iteration, char is going to be A, and the Morse code in square brackets char is going to be Morse code in square brackets A. So it's going to go to our Morse code dictionary, and it's going to take the representation of A in Morse code, and it's going to add it to our translated message each time. And since Morse code is written with each character followed by a space, we're also going to add a space after each character. And finally, we're going to have an else statement. That means if it's not inside our Morse code dictionary, then we just wanted to add a space to our translated message. So we're just going to do translated message plus equals an empty space. That is if the character is not found in our Morse code dictionary. So once we do that, we can get out of our for loop and we're going to print a formal message of our Morse code. So we can say, using formatted strings, we can say translated message semicolon, and we're going to put in our translated message variable, which is going to be consisting of Morse code. So now we can save our file and see if everything works. So we're going to run it from our terminal using Python 3, followed by morse.py. It asks us to enter a message. Let's just put in hello and press enter. As you can see, it translates our hello message into Morse code. Let's just, for the sake of example, let's just try a longer string. So we're going to run our program again, and we're going to put in hello, my name is Abel, and this is my YouTube channel. And we're going to press enter, and again it prints out the Morse code. So this is a very interesting project, and for those of you who want an exercise, you can build the reverse of this. That means a program that takes in Morse code and it's going to convert it into normal English. So that is an exercise if you want to do it. So on this project, we're going to be using an API. So first thing we're going to do is get our link. So to get the QuizGame API, we're going to open our browser. Then we're going to search for QuizGame API. Then we're going to pick the link, which is from the website opentdb.com. So we're going to open that website, which is going to provide us with the quiz API that we're going to be using. So here it gives us different options. So for our quiz game, it's going to be 10 questions and it's going to be a true or false question. So that is what we're going to do. So we don't need to change the number of questions. We can select a category if we want one. Here we're not going to select any. For the sake of an example, we're just going to pick the easy difficulty and we're going to select a type. So in this one, we're going to be doing a true or false quiz. Then finally, we can press on generate API link to get our API link. So as you can see here, we have our link. So we're going to copy it. Then back in our editor, we're going to create a new file. We're going to call it quizgame.py. And what is our plan here? So first we're going to be importing requests so we can use our API. Then we're going to get the length of the result. Then using that length, we're going to have a for loop that's going to run 10 times in our case, because we're going to have 10 questions. Then in each iteration, it's going to print out the question and it's going to ask the user true or false. Then it's going to check if their answer is correct. Then based on that, it's going to increment their score if they get the answer correct, or else it's going to print out incorrect. And finally, it's going to print out their result. So first we're going to have our import statements. The first one is import requests. Then we're going to have a variable called, let's just call it quiz data, which is going to get our API. So we're going to have requests.get. Then inside the get function, we're going to provide the API we got from the website. So we're going to paste it in here. Then once we have our API, we're going to print out the JSON formats so we can see what we're going to be dealing with. So let's just print it out. So let's print out quiz data.json. We're going to save our file and we're going to run it. So this is the JSON format of our questions list. So as you can see, we have response code, we have results, we have category, we have type, we have difficulty, then we have question. That is what we need, the question parameter, because that is what contains the actual question. So using that, and we're also going to be using the correct answer parameter, which is going to store the correct answer. So we're going to be using those two to display the question to the user and to check if the user's answer is the same as the correct answer. So first we're going to have our length variable, which is going to be equal to len of quiz data.json. So now we're in the JSON format. Then we want the results key. So inside the results key, it's going to be a list, and this list, the length of this list is going to be equal to the number of questions we have. And we can get rid of the print statement because we don't need to print it anymore. Then once we have our length, now we can start our for loop. So we're going to say for I in range length. So this is going to run 10 times. So for clarity purposes, we're going to print out I plus 1. So what this is going to be is the first is going to print out 1 followed by the question, then 2 followed by the question. It's just the number of questions. So it's going to be I plus 1. Then we're going to use the end parameter for print. So what the end parameter does is it's going to change the default value for end. So the default value for end of a print statement is a new line. That means after we print something, the print function is going to end with a new line. So if we print hello world, then it's going to end with a new line. So if we want to change it with something else, we can using the second parameter. So we're going to say end equals, then we're going to have a closing bracket followed by a space. So this is just going to be 1 bracket followed by the question, then 2 bracket followed by the question. And that is how we're going to be displaying our questions. So once we've displayed the number, the next thing we want to do is display the actual question. So we're going to have another print statement, and this time we're going to print out quiz data.json again. And inside the JSON format, we want to go to results. Then inside the results key, we want to access the ith key. That means for the first question, I is going to be 0. For the second question, I is going to be 1. So it's going to go all the way to 9. Then inside that, we want to access the questions key. So this simply is, we can look at the JSON that we printed before. So first it's going to go to the JSON, then it's going to go to the result keyword. So here is the results keyword, and the results keyword has a list. So in this list, there's a dictionary. So once we are in the list, we're going to access the ith element. So each dictionary is one question. So the ith element is going to be different questions. Then inside the dictionary, we're going to be accessing the question key, which is going to contain the actual question. So once we've printed out the question, the next thing we need to do is ask for the user's input. So that means it's either going to be true or false. So we're going to have a variable called user answer. So the user answer is going to have an input, which is going to ask for true or false. Then we want to capitalize our user's input. The reason we're doing that is because when we look at the correct answer key, the word true is the first letter is capitalized. So we want to match that. So we're going to capitalize the user's input. Then once we have the user's input, we're going to compare. So we're going to have an if statement. So we're going to say if user answer is equals to quiz data.json, Then we're going to go to results, and we're going to go to I. Then we're going to go to the correct answer keyword. So we're going to have correct underscore answer. So this is going to access the ith element. That means it's going to go to results. So for example, when I is 0, it's going to go to results, and it's going to go to the first element. Then it's going to go to the correct answer key. Then the correct answer key contains true, so it's going to compare true to the user's input. So if it is equal to the correct answer, we want to print out correct, followed by a new line just for readability purposes. Then we want to increment the user's score by 1. Actually, we haven't defined our score variable, so we're going to do that. So here we're going to have a score variable, and we're going to set it to 0. So it's going to increment each time the user gets the question correct. And we're going to have an else statement. If the user doesn't get the question correct, we're going to print out incorrect, followed by a new line. And finally, when we're done with the for loop, that means we're going to print out 10 questions, and we're going to compare each answer of the user to the answer of the question, and we're going to increment the score if the user gets it right, or else we're going to print incorrect. And finally, when we are done, we're going to print out their result. So we're going to say print, and we're going to tell them you scored, followed by the score variable, out of, followed by the length variable. So let's say they answered 5 questions correctly, so it's going to say you scored 5 out of length is going to be 10, so it's going to say you scored 5 out of 10. This needs to be a formatted string so it can accept the different variables. So this should work properly, so we can now save our file and run it. As you can see, it's printed out the first question. It says, in the, followed by some gibberish, film franchise, Donkey is played by Eddie Murphy. So why are we getting this gibberish? That is because the API is returning our question, and it's using an HTML format. So that is why we're getting these. So there is an easy way to fix this. So we're going to have to use another library, which is the HTML library. The HTML library contains a function called onEscape, which converts HTML components to strings. So we're going to be using that. So we're going to go back to our file, and we're going to import HTML. Then we're going to go to where we printed out our question. Then here we're going to add html.onEscape. Then in parentheses, we're going to have our question. So this is going to convert the HTML component to a string. So now we can save our file. The other thing we need to do is check if we got the link correctly. We can do that using the status code. If the status code is equals to 200, that means we got our link successfully and we can continue. If it's different from 200, that means an error has occurred and we did not get our link. So what we're going to do is we're going to have an if statement that's going to check the status code. So we're going to have if quiz data dot status code. That's how we access the status code. And if that status code is equals to 200, then we want to do everything. So we're going to indent the whole code we wrote inside the if statement. Then if our status code is not equal to 200, we're going to have an else statement, which is going to print out an error has occurred. So this is all the code we need to write. Now we can save our file and we can run it again. So we're going to quit this and we're going to clear our terminal. Then we're going to run it using Python 3, followed by the name of our file. As you can see, there is no HTML anymore and it's working correctly. So let's just go through one round. It says a slug's blood is green. Let's go with through. So it prints out correct. and it prints out the second question, which says, pointers were not used in the original C programming language. They were added later on in C++. We're going to go with false. We're correct. The third question says, Peyton Manning retired after winning Super Bowl. We're going to go with true. We're incorrect. The fourth question, former President John Adams and Thomas Jefferson died within hours of each other. We're going to go with false. Again, we're incorrect. The fifth question, in Splatoon, the Squid Sisters are named Taco and Yaki. Let's just go with true. Again, we're incorrect. The sixth question, the Pepe meme originated from a comic drawn by Matt Fury called Boys Club. Let's just go with true again. We're correct this time. The seventh question, in Sonic the Hedgehog universe, Tails' real name is Miles Prower. We're going to go with true. We're correct. The eighth question, in RuneScape, one must complete the Dragon Slayer quest before equipping rune platelets. We're going to go with false. We're correct. The ninth question, in Heroes of the Storm, the Cursed Hollow map, gimmick requires players to kill the undead to curse the enemy team. We're going to go with true. We're incorrect. The 10th question, Slovakia is a member of European Union. We're going to go with false. And we're also incorrect. As you can see, we scored 5 out of 10. So these are very random questions, but if you wanted a specific category, you can go back to the website and pick which category you want. Again, you can also change the number of questions. And finally, you can also change the question type. That means you can make it a multiple choice question. So this is it for our quiz game using the requests and the HTML library. So this has been 8 beginner projects in Python. If you enjoyed the video, you can show your support by liking the video and subscribing to the channel. And if you want access to different exercises and resources, you can join our Telegram channel.